Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And there's a really good example this week on the forecast weather maps of what we call a lee trough. And lee meaning leeward of the Appalachian Mountains. You can also get this even to a greater degree east of the Rocky Mountains. And it's basically caused by when air approaches a mountain range from the west, things happen to it, which then dictate the pattern of the isobar. So I thought we'd talk a little bit about that today and show you a real world example of it. So let me put myself down here in the corner before I start to obscure things. So how mountains affect vorticity, or spin in the atmosphere, if you will. So let's start off with our trusty mountain range here. That's the best I could do on that. And we have an air column, and it's approaching that mountain range from the southwest, say, okay? So the isobars would be fairly straight here. Now, as it approaches the mountains, it can't just, move the mountain out of the way. If that started to happen, we'd have a whole other problem. But the air starts to get compressed vertically, but overall, air is incompressible, and so if you squish it this way, it's got to expand that way, okay? So then that same column of air starts looking like this, okay? It's wider than it is tall, as opposed to initially when it was taller than it was wide. So when that happens, think of the example of the skater, where if they pull their arms in tight to themselves, then they spin faster and faster. Well, by the same token, if they spread their arms out and they diverge horizontally, that's going to make them spin slower. So this effect that the mountain has on this air column actually decreases vorticity, and the isobars start to bend anticyclonically. In other words, if you had a sort of, imagine you have a map here, and if a high was sitting down in here, the air would be going anticyclonically around that high, okay? So the isobars start to curve in an anticyclonic manner as that air goes over the mountain range. However, as it gets on the east side of the mountains, then this is what happens. We have horizontal convergence and vertical divergence, so now we're back to taller than we are wide, and that increases vorticity. That's the skater pulling their arms in closer. And so now the isobars, instead of curving anticyclonically, start to curve cyclonically. And you end up getting a trough east of the mountains, or what we call a lee trough. And sometimes, especially in the convective season, these things can kick off showers and thunderstorms. So let me give you an example of a forecast map that I showed in the daily weather update for Thursday at 2 o'clock. And you can see how the isobars dip here up around Washington, D.C., and there's sort of a trough axis that goes all the way down like this. So look at this. These isobars are fairly straight until they get to the mountains, get to the Appalachians, and then they curve anticyclonically right in there. And then as soon as they get east of the mountains, then they start to curve the other way, cyclonically, okay? So you're going to have convergence along this trough axis with northwest winds here and southwest winds here. And many times those trough axes can act as triggers for showers and thunderstorms to develop. Anything that makes the air come together and go up, that's always a recipe for cloud development. And if it's vigorous enough, showers and thunderstorms. So I thought it was such a clear example this week of that would be an interesting thing to talk about, why that shows up the way it does. Alrighty, that is bonus weather video number 1 for this week. The next one will be up on Wednesday, and of course the next daily weather update coming up tomorrow, and we'll be taking a closer and closer look at that big upcoming holiday weekend, I guess the unofficial beginning of summer in a lot of people's minds from a recreational standpoint, first big one of the summer. All right, folks, that's it for now. You have a great Monday evening, and we'll talk to you again tomorrow. See ya.